So solving exponential equations. So we looked at logarithms, we've looked at exponents. Now we need to kind of use them both in order to solve. We have two methods of solving exponential equations. The first method is the common base method. So we want to turn both our exponents to where they have the same base, and we can actually just eliminate the bases and we're left with just the exponents. So here's how we do it. Method one. We look at our equation. So we've got 4 to the 2x plus 3 equals 32x. And so what we want to do is we want to change these to where they have the same base. So we can take 4 and 32. Those are both powers of 2. So 4 can be written as 2 to the second power. We also have that 2x plus 3 that stays there. And 32 can be written as 2 to the fifth power. And that x as the exponent stays there as well. So we can find these exponents fairly easy, or these powers, if we use our power chart to just look it up, right? So if we're looking at our power chart, again, the way we got this 2 squared and 2 to the fifth is they're both in the base of 2. So we have 4 and 32 in that same row. So we're just using that same base, 2 squared and 2 to the fifth. Okay, so that's how we find that same base. So then, going back to our notes. Once we have the same base, we can eliminate the bases. So the 2's disappear. The base is the same, that means the exponents must be equal. So we have 2 times 2x plus 3 is equal to 5 times x is just 5x. Okay. We can go ahead and then distribute our 2 as well. That gets us 4x plus 6 equals 5x. Then we want to solve for x, so I'm going to subtract 4x over. And we're going to get 6 equals x. That's how we solve using one of our methods of the common base. Again, what you're doing is you're taking your exponents or your bases, changing them to the same base, therefore you can eliminate them, and you're left with just the exponents, and you just solve your exponential equation. Okay. The second way of solving is when we use our logarithms. So this is going to be used with a calculator because you can't do these by hand. So we have 6 to the 3x equals 24. And so what we want to do is we want to actually take the logarithm of both sides. We're going to use our common log, and it's just a base 10 logarithm. So we have log 6 to 3x equals log of 24. Then we can use the power property of our log rules. Okay, so our log property, we can take this exponent on our logarithm, bring it out front. So that gets us 3x log of 6 is equal to log of 24. We want to get rid of this logarithm on this side. So we're going to take that and divide by the log of 6. Do it on the other side as well. So that cancels those out. So that leaves us with 3x equals log of 24 over log of 6. Well, again, we're still solving for x, so we'll divide those by 3. I'm just going to throw it out here to the side. And here's where the calculator comes in. We're going to plug this entire thing into the calculator at once, because we don't want to round it. If we round it too early, it's going to give us an incorrect answer. So on the calculator,
Can I see one of these power charts? Do you
yes,
have one?
yeah, you can take that one.
That one? Okay, thank you.
What we want to do is we want to start with the log of 24 divided by log of 6. Make sure when you plug it in, we close the parentheses on that first one and on the second one. So log of 24, close your parentheses, divided by log of 6, close those parentheses, and then we're dividing that whole value by 3, so we can then just say divided by 3. You can do this and then divide that by 3, and we get the value of 0.5912. I can't remember if the homework wants you to go to 4 or 3 decimal places. Once you go to 4 decimal places. So that's how you do it. Okay, we've got these two different methods. Common base, change your bases to the same, simplify it by getting rid of them, and you're left with just the exponents. Or take the log of both sides, divide by the log first, and then do any other operations that you would have to your x to get it by itself. Let's do a few of those problems together. So on the front page of the homework, these are all common base. So we can turn each of these to where they have the same base to solve. So let's look at the first one. Number 1, we've got 5 to the 2n equals 125. So there's a big hint right here. 5 is going to be our base, right? We can't reduce 5 down any. It's a prime number. What can I turn 125 into with a base of 5? 5 to what power? Third power. So we have 5 to the 2n equals 5 to the third power. They have the same base now, so we can essentially cancel the bases, because if the bases are the same, the exponents must be equal. So we have 2n equals 3, divide by 2, we get n equals 3 halves. Okay.
I kind of like this. Okay, well, that seems simple.
Seems real simple.
Yes.
So let's pick some of those other problems from the front page. Pick 2 more.
8. Yeah.
Number 8.
Yeah, we do 7 and 8.
7 and 8. Let's do 8 first.
Yeah, 11 too.
So 6, negative 3n minus 3 equals 1. This was a little bit tricky. 6 is our base. How can we turn a 6 into a 1? 6 to what power gets us 1? 0. So 6 to the 0 power gets us 1. Now we have the same base. We can cancel out our bases. So we have negative 3n minus 3 equals 0. Solve for n. So we're going to add 3 over. Negative 3n equals 3. Divide by negative 3. We're going to get n equals negative 1. Okay. What was the other number? 7. 216 to the 3a plus 1 equals 36. Okay, so again, not quite sure what base to use in this case. Okay, so let's look at our power chart. And we want to find 36 and 216 in the same row. Okay, so if we're looking at our power chart, I know 36 is a multiple of 6, so there's our 36. And 216 is also a power of 6. So we can turn these both into a power of 6. So 216 is 6 to the third power. So we do 6 to the third. That 3a plus 1 just stays there. And then we can turn 36 into 6 squared. They have the same base. We can mark them out. So we have 3 times 3a plus 1. So we can go ahead and just distribute that. So 3 times 3a, we get a is 9a. 3 times 3 gets us 3 equals 2. So then solve for a. Subtract our 3. 9a equals -1. Divide by 9. A equals -1/9. Oh. So again, really this method's not too bad, right? Find that same base that they have in common. Put your exponent on top. If there's anything else on top, you're just going to multiply those two exponents together, your new exponent and what was ever originally there. And then take those exponents, set them equal to each other, and solve from there. Okay. Let's look at the back page. So this is solving logarithms with our logs, or our exponents with our logarithms. Let's start off easy, then we'll do some of the harder ones. So number 13, they've got 9 to the a equals 49. So again, first step, take the log of both sides. So that's going to get us log of 9 to the a equals log of 49. Again, our power property states we can take this exponent of the a, bring it down out front. So that's going to get us a log of 9 equals log of 49. Then we want to divide both sides by the log of 9 to get rid of our log of 9 on the right, or on the left. And that leaves us with just our a on the left side equals. Here's where we plug it in the calculator, right? We're going to do log of 49 divided by log of 9. Round it to the 4 decimal places. So we got log 49. Make sure to close those parentheses, divided by log of 9. And we get 1.7712. There we go. Pick 2 more of those that you want to do. 22. So we have 3 and 2.5x plus 3 equals 89.7. Okay, so this one's a little bit more complicated. They're adding in a step before we take our logarithms. So when we take the log of both sides, we want to have some number equal some other number. This time they're giving us a plus 3. So we want to move that plus 3 to the other side first. So how do we get rid of our plus 3 on the left side? Subtract 3 from both sides. Equals 86.7. Then we're going to take the log of both. So I'm just going to throw my log in front. Again, that then allows us to move my exponent from the exponent and multiply it down in front using that power property. So we have 2.5x log 3 equals log 86.7. In that second step, or third step, I guess in this case, divide by that log 3. So that's going to get us 2.5x equals this log 86.7 divided by log of 3. And we're going to divide that value by that 2.5. Whatever we get from there. So our x is going to equal, again, we want to plug it all in, do the log division first, don't round it. So we got log 86.7. Make sure to close those parentheses, divide by log 3. Take that value and divide it by that 2.5 that was in front of our x. And we get 1.625. Oh. 48, I mean. Any questions on that? So you guys want to pick another one? 23. For e n minus 3 equals 29. Okay, so this one's a little confusing when we look at it first. This 4 is not being raised to that n minus 3 power. So we can actually divide by 4 before we get started. Okay. E itself is a number. That's the natural number. It's on your calculator. It's right beside the division sign. Or actually, that's how you get its second division. So we're going to divide both sides by 4. That gives us e to the n minus 3 over, I'll just leave it as a fraction, 29/4. Then we want to take the log of both sides. Again, that's going to allow us to take that n minus 3, bring it down out front. And n minus 3 times log of e is equal to log of 29/4. Divide both sides by log of e. So it gets us n minus 3 is equal to this. So what we would do then is add 3 to both sides. So I'm just going to add 3 up here. So then we can plug that right to our calculator. So we've got log of 29/4.
Where is E on the computer?
So E is second and then your division sign.
Okay.
So log 29/4. Make sure to close those parentheses around that. Divided by log of E. And again, the E is your little blue second division sign on your calculator. And then once we've done that, hit enter, and then we want to add 3 to it. So that's our last step. Add our 3, and we get 4.910. 4.9810. Okay. So again, you're going to be following those same basic steps every time. But first, you want to isolate whatever is being raised to that exponent. Any questions?